what we do in 2021.ai is that we are working with companies to develop and deploy and operate AI models in production. So that's sort of the general value that we are trying to bring to the customers, and we do that by offering a technology platform, doing scalability, doing it in a cost-effective way, making sure that these models are retrained, and that these models are sort of managed in various ways, and then finally offering also the risk and compliance angle to these AI models and these machine learning models, because what we're seeing in the marketplace is that to an increasing extent that there's a lot of work to be done in terms of the risk and compliance within AI going forward. But enough about that. Let's move back to what is actually what is we talking about, and basically what we're talking about is what is the difference between a traditional piece of software and then a machine learning model. And basically, if you look at it, you can say an expert model is basically just a series of if then else statements. If you look at it from a perspective of saying I want to figure out what is the price of my house, I could say, well, is it a good neighborhood? And if I say yes to that question, then does it have a garden? And if I say yes to that question also, it's probably expensive. But if it's not a good neighborhood, if it's an old house, then probably then probably the house is actually quite cheap. But it's also building a software system out of if then else statements becomes also quite intensive, and you need to have a lot of knowledge around the area that you're actually working in, versus machine learning models where you can say that the input variables are actually given, and then you basically feed it through a model, a network of neurons, can you say, in the sense of neural networks, and then based on that you actually get a price. And the advantage here is that one, you don't necessarily need that much expertise within a specific area to build a model that can predict this price. So there's there's very little sort of expert knowledge involved in building these kinds of models. And the other thing is that it is able to act on previously unseen data. So if you have a house which has a medium good neighborhood and has a small garden and is medium aged, then it's still able to give a price that comes out on the other end and being more correct than you could have maybe done as building an expert system. So all of that is based around the fact that it needs to have data initially. Whereas with the expert model, you don't need to have data up front, you just need a lot of knowledge. Whereas with the machine learning model, you need to have data in order to begin your model development journey. And that's a very different approach from if you look at it from a traditional product management perspective. So it all starts with the data in typically, and it's all about pattern recognition. So basically, diving a little bit more into that in terms of the development journey, you can say again in the classical software development, you have some input, you have some code, and outcomes a result. Whereas in the machine learning development area, you provide the input, the input data, and then you also provide the resulting data, right? And then out of that comes a program, and that's a very different approach from the traditional ones. If you look at that again for the housing price situation, you can say again in the classical software development world, you would input the housing data, you would input some expert knowledge, and out would comes a price on the other hand. Whereas with the machine learning development, you input the house data, you input the result of it, right? The actual prices as seen in the marketplace, and then from that comes the actual model that you can then reuse again and again and run that also on previously unseen data. And this is where things are very different from a traditional software development project. So going a little bit into what kind of types of machine learning and AI there is out there, you can say that if we start with the basic machine learning, there's a whole domain of let's call it classic machine learning, and the first class here is the unsupervised classes of machine learning, where we're talking about unsupervised learning, which is basically that you don't necessarily set a target function. You just identify some clusterings and some different areas of a multi-dimensional data cloud. And then you say, well, are there any distinct characteristics around this? And then you can use that to build some models. You can use these kinds of models are typically used for predicting larger classes of data sets in a sort of a batch approach. And then you have the more classical supervised machine learning, which is based on the fact that as with the house prices here, you have some input data for the house price. Sorry, for the parameters of the house. Is it old? Is it new? Does it have a garden? And all these kinds of data. And then there's also a price, which is what we're trying to predict for previously unseen data. And this is a typical supervised machine learning area. And there's some subsections here, linear regression, which is a very sort of simple or pretty simple statistical model. There's a traditional classification, but then there's also some methods which lies, sort of in a boundary between classical statistical methods and then deep learning as well, which is some of these ones, random forest, XGBoost, and so on. And on the other side here, you have stuff like reinforcement learning, which is basically where you're trying to build some learning around, so that the models themselves can evolve within some boundary level conditions. And then finally, you have what you might see somewhere in the news is the neural networks, which also has a lot of different areas. There's both the networks for identification of objects in images, of sounds in audio, and obviously looking at larger quantities of text and being able to classify it or stuff like that. So regarding the possibilities, you can say the possibilities are obviously endless. It's typically around, recommendations, predictions, forecasting, classification, recognition of something, scoring of something, detection of something, and scanning. And these are typically done on data like structured data, which is like, a table in a database. Could be unstructured data as, a large quantity of text, or it could be time series data, like you see, we're in a factory where all these machines are generating different kind of time series data related to a specific series of time. And then you have the audio data, you have the images, and then you have the videos, which all of them has, each of their own areas within data science and within machine learning and AI that is itself very interesting. And obviously you can also, do combinations. So if we imagine the same scenario as with the house prices before, but then you add, images of the house inside, and then you are able to compare parameters from the house with actual images from within the house, and based on both the images and the parameters of the house, you can then get an even better price a prediction for that particular house. So all of this was a little bit around machine learning and AI and how that fits together. You can say, but the primary problem for a product manager in this situation is where to start, right? Especially if you're coming from a small and medium-sized organization where you might not even have a product yet. You might not have any users. And then if you don't really have a product, if you don't really have users, then how can you do machine learning? Because the problem is that the more users you have on your product, the more data you can then potentially get. And when you have more data, then you can also improve your product. So this is sort of both a positive circle, and it's also a bad circle, right? Because if you are in the beginning of any kind of product development journey, then it's very difficult for you to build a good AI product if you don't have any users, if you don't have any data. So that's very difficult. So one of my recommendations, and we'll get to that later, is that you should also be not be afraid to go out in the market and find find data, either some public data, or it could be also to buy data from various companies to improve your product over time. So that's a very important aspect, is to be aware that if you don't have any data, it is quite difficult to build a machine learning product. So looking at this from a product manager's perspective, then you can say you have I call them the 4 pillars, and obviously that starts with the data. It starts with the model, and these areas are typically seen from a data science perspective. It's around getting the data, doing the quality checks and the testing of the data, cleaning the data, making sure the data is ready for training, then training the model, then testing the model, and then finally deploying and operating this model in production. So all of this is within the blue circle down there, which is typically stuff that the data scientists are doing. But when the model is put into operations, then typically it's within the orange circle, within IT, which is typically like IT infrastructure kind of things, because the problem with AI models, both when they're being trained and also when they're being operated, when they're being run in production, they can require quite a bit of infrastructure. So some of these models, if you take an image recognition model, for example, that typically needs to run on a GPU machine, so like a machine that has a graphics processor unit inside of it, and that's quite expensive to run in a cloud environment. So therefore, these things needs to be managed. Or if you run it on your own computer, then you need to make sure you have the necessary requirements for that. So those are 2 very important aspects when you're working as an AI product manager. But obviously, the most important one is that you have business value. So because, and I'll get more into that later, that you should be super focused on creating business value and not just focus on the hot and sexy AI models, but rather on what is creating value for this company right now in this instance. So that's important one. And then the gray circle there, governance, that's also something to be aware of, and a new emerging area, can you say, which is about looking at what is the potential risk for the company of implementing and deploying these AI models, both looking at it from a perspective of using of personal data, and what are this personal data, what is that being used for inside of the models, and how these models being developed, and how these models being deployed and operated, especially when it comes to things like bias and bias management and bias mitigation, but also in terms of cybersecurity and potential risk of being compromised. So there's a lot of areas there. And then finally, there's the area within governance around the legal aspects and making sure that you're compliant with the legal perspectives of this. And I'll get back to that also. So basically, now let's dive in a little bit into the pitfalls, right? So imagine now that you are an AI product manager and you're starting the project. So the typical sentence you will start to say to the business side is that AI can do anything, and that's not entirely accurate. You can say that and I think this is a good depiction of that. It's a big mess of data, and maybe if you stir the pile a little bit, then sometimes some good stuff might come out of it. But in many cases, it's just the crap that comes in and crap that comes out the other side. So my advice is that start by writing down some hypotheses, some statements that says, can we try to do this in this domain, and then try to prove them using some identified data sources and doing some initial data exploration. So I really encourage you to write down some business opportunities and sort of annotating them with individual complexity, with some business value. Do we have the data? What kind of source quality is there, or data quality? what kind of customers would be interested in this, and so on. So start by doing that, and then start by doing a lot of them, because then if some of them fail along the way, then you have something to sort of come back to if things are not working out as they should. So that was pitfall number one. Pitfall number two is AI is always the answer, which again is not really true. So this guy here, Abraham Walsh, so he was actually living in New York during the Second World War, and he was sitting in a team called the Statistical Research Group, and they were doing research on bomber planes coming back from the Second World War, and they were looking at bullet holes within the individual planes and saying, because they wanted to do build additional armor on the actual planes, and then they looked at these holes and then they said, yeah, that looks great. Where all the bullet holes, where the bullet holes are, let's build some armor there, because that's clearly where the planes are being hit. And and then Abraham, actually, he was a smart guy in that team, and he come out and he said, guys, that's not true. The reason why you don't see any bullet holes in the cockpit and around the fuel tanks is because these planes didn't make it home. So that's food for thought, that you should always worry about. Maybe I have some data, but maybe you need to look where there is no data today, and then see if you can get that data somehow. And also be sure to have some technical understanding of the area that you're working in terms of AI and ML. So if you have a lot of use cases surrounding NLP, natural language processing, be sure to look into that, and so on and so forth. The third pitfall is data makes a great AI. That's not true. You can have a lot of different data. You can have the fantastic pie chart like this, and that doesn't mean you have to build an AI machine learning solution on top. And also, just because you have the data does not mean that you have the right data. So make sure you have the right data and high quality data that is actually usable for building these models, especially in terms of the predictions that you want to make. And that's the thing that a lot of people don't realize, is that you might have a lot of data, but you need to annotate this data and have the right labels on it in order to be able to use it for a machine learning model. And don't be afraid to go out and buy it. Don't be afraid to build synthetic data if you're trying to do something which is like, where you want to have some specific behavior out of it. As long and realize also that data is really the frame around your AI painting. So I think that's an important point. The next pitfall is actually that complex models generate most business value, and I think there is a little bit of truth in that. As a business, if you look at it from a business perspective, really focusing on AI, can make sense, but when you start as a product manager developing your first AI product, then I think it's very important to focus not on the very complex models, because then what will happen is that you will eventually crash and burn. So what you need to do is that you need to think about, how can we minimize the risk for a particular product. And that's typically building very simple models, even just building the expert rule system that I showed in the beginning, like a lot of the if-then-else statements, just to get something and to get started on something, rather than building a huge and complex model where the risk of failure is high and you have a lot of high risk of running out of money very early on. So please be aware of that one as well. Number 5 is that AI and machine learning products are quick. They're not. And in fact, building the actual model is a very small part of it. If you just look at the data science part of it, there's a lot of areas around data collection, around data testing, verification, and finally operating these models. That does require a lot of time and a lot of effort for the data teams and the IT teams to do this. So my advice is to look at platforms, look at systems out there that can support, the AI machine learning development journey that you're on, and the products that you're working on, and make sure that you can use these to scale sort of your product and govern them as well. Pitfall number 6: no testing is required. Not true. In fact, I think in terms of testing, for AI machine learning models, there's a lot more testing than there is. It's all the software testing part, but then there's also the data and the model part, which also needs to be trained. So a lot of testing is required, and the testing is not just in development as it is with normal software products. It's also after you have deployed and are operating these models, it also needs to be tested continuously. So it's a very important point. Test, both in development and test when you are in production and after running in production. And there's a lot of areas around data science testing, a lot of new concepts. I'm not going to go through all of them now, but just say that there's a lot of things to be aware of there. Number 7, once projects are done, they don't require maintenance. Not true. So if you have, a model that's been running for some time, then what actually happens in real life is that they have a tendency to get dumber. So models get dumber over time, and models can even be very damaging to the company if they're not properly retrained. So my example of that being a churn model that's running in a financial organization and has been so for the last 5 years, and nobody really looked into it. And it turns out that it's actually, doing a lot of things in the company that is actually more damaging than it should be, or more damaging than doing good stuff in the company. So always find platforms that can automate the retraining, the recalculation of bias and accuracy. So make sure that you're still at the level where you want to be in terms of, every time new data comes in, because almost all models, I mean, there's a few exceptions, but almost all models, they require retraining at some point. Doesn't matter if it's image recognition, video recognition, if it's, structured data models like, forecasting models and so on. The data surrounding or the environment surrounding these models changes over time. So be aware of that and also think that into the project and the project plan as such. Number 8, trust doesn't matter. Not true. Trust has a lot of, or is a very important aspect for product management working with AI. Think about things like transparency, fairness, accountability, privacy, obviously, explainability, explaining the results of these models to the customers and users that are going to use these products, and also explainability even internally in the company, right? So when launching these products, how what kind of transparency does these models have, and so on. This is a very important aspect. You are the front gatekeeper for bias, for fairness, for explainability, and privacy issues when it comes to this product. Not anybody else, just you. So be aware. Finally, rules and regulations is not important for AI. Not true. In fact, there's a lot of different regulations out there in terms that are targeting more or less, or in some ways or other ways are targeting AI models and also processes. And I think the good example is Fodino, which is an Italian food delivery company that was just here the 10th of June this year, was fined 2.6 million euros. They have around 19,000 riders, which is like bringing food around to users out there. And they have two systems. They have sort of a scoring system that scores each of the riders in terms of how good they are to bring out the food. And they actually got this fine because the algorithms and the models they built, they were not transparent. They had no fairness involved. They had no way for the riders to be able to communicate with the company in terms of asking questions, stuff like that. So there's no transparency. There was no fairness metrics, and there was no accuracy also around the models. They were probably really great at delivering food, but it was not really benefiting the people that were working, delivering this food. Right? So that's an excellent case. I'm just mentioning this one because there is like 1,000 cases out there, which is much worse than this one actually. But I think this one is a very recent one, and the verdicts and the way they got defined was very, very, very clearly defined in the in the find they got. So make sure that you know what kind of industry you're in, and the model type that you're working with, the kind of data that you're working with, and then look at the legal perspective and make sure that you have everything covered before you go out and deploy and operate AI products out there. Because I think if you don't do that, you might get on the front page on a newspaper somewhere, or get a fine, or both. So make sure you look into that before you start releasing these products. And finally, always elements around cybersecurity, data anonymization. There's a lot of security and regulatory things you need to look at when it comes to AI models that are specific to that area, not just on software in general. Finally, AI pitfall number 10, all data scientists are gods. Not true, although I think this is a god. So basically, if you look at data scientists as a whole, their skills are very different. And they have, first of all, there's different areas of data science, right? There's image recognition, there's NLP, there's structured data, there is, recommender systems, classification systems, and so on and so forth. So there's a whole world of different, mathematical areas and the machine learning areas that require different skills. And then on top of that, there's also a lot of different areas within data science, kind of different roles within data science that you can do. For example, data engineers are working more on the data ingest side and sort of processing and making sure that the data is ready for being trained. And the data analysts are sort of making some initial, analysis and maybe some initial dashboard to draw on. And you have model deployment, you have data architects, analytics managers, and so on and so forth. So there's a lot of different roles. And also realize that these kinds of projects are not just around data and models. It is a team effort. It's also business. It's also IT infrastructure people. It's also UX UI people that needs to be involved. So it is a team effort, and please see that as that, and not just do something together with the data scientists. I think you're done, right? And typically, if you go out and want to find data science skills, focus on people that have some open source experience, are working with Python, because this is the most used language and tools that the Python ecosystem offers in terms of developing and deploying these kinds of models. And finally, start simple and then build complexity on top of it. And also, I think it's important that you, if you look at it from a skills perspective, then if you are starting a product or a product journey, then it might be easier to get sort of, you don't need you typically can get someone with relatively low skill in to do some initial work, and then once you move further and further into production journey or into releasing the product, then the skills needs to improve, which is sort of the other way around in a traditional software product where you start with the high-paid architects, and then you go and then you start the architecture, and then you work your way down in the solution that way. So it's a little bit the other way around.